Using OpenSpec to create a web application with GPT Codex in VS Code. In this Spec Driven Development series, I'm creating a car classifiers website. This video will be creating the data access layer from an existing database schema. If you have not already done so, make sure to watch the previous video where I scaffold the solution structure using an AI an agent skill. Now, there are a number of ways of implementing data access. I will be using my own custom libraries in a NuGet package simply to cut down on a lot of the repetitive boilerplate code. Here is the database that already exists, and this is going to be more of a database first design as opposed to doing model first. This simply means the entities from the domain will be created from this existing schema. Now, ultimately the goal is to have the AI agent, which is GPT 5.3 Codex, create all the domain entities, wire up all the entity framework configurations, similar to how this solution has been completed. There are a lot of database tables, and the entities must be grouped by functionality, similar to the concept of a bounded context. Also, I'm making use of a lot of DTOs or data transfer objects. And just looking at this existing code, to wire up all these tables to follow a lot of the best practices is a lot of time-consuming repetitive work. And ideally, this should be already a trained agent skill that would complete this task very quickly. I have the option of developing that skill to be also reused in other applications, but in this case, I'll just use an existing PowerShell scripts and some of the instructions in MD files. So those instructions are going to tell the AI agent how to sort of scaffold all these projects. So that's the high level goal. Now, here is where things can get a little bit confusing, and maybe we can just go through the actual role of OpenSpec in this case. Just a reminder, OpenSpec is not an AI agent. It's not going to be doing the lower level labor of generating all of this code. Instead, the agent is going to be GPT 5.3 Codex, and obviously any other model can also do this sort of labor. What OpenSpec is going to be doing is to break down this relatively large request or task or change proposal into detailed plans and steps. So now the AI agent is simply going to just carry out those steps or those tasks. If this data access layer was the only milestone in this entire application, OpenSpec would be almost redundant, especially if there was already an agent skill that can simply generate all these projects from the schema. Okay, now let's just get our hands dirty and start building. So this whole data access layer is going to be a change proposal. The high-level steps are actually quite simple. The summary is that you have a proposal, then you go through approval, tasks are generated, and then the AI agent is going to execute all the tasks. Very important detail, if you are prompting the AI agent, you should maybe as much as possible avoid saying things like execute all the tasks, as now this entire process is going to downgrade to vibe coding. The human has to be involved on every little task and approval. So that's what spec driven development is about, is that you're not letting AI go off in its own little tangent. So now, following the steps, we gonna get OpenSpec to scaffold the change proposal files. You can think of these as details of what this new feature is going to be about. These files are scaffolded, proposal, design, tasks. A developer just has to fill in the details of these tasks and then simply instruct the agent to start executing each task one by one. It is crucial the developer takes the time to read and review all these documents. So an AI agent such as GPT 5.3 Codex are actually very, very, very robotic and are going to follow every little step literally without any intelligent thinking. So I don't think there's going to be a point where a developer can blame an AI for not doing anything correctly. Now, actually executing the proposal, here are some of my honest, unfiltered opinions. There was a lot of repetitive labor to be done. For this exercise, like I've said before, OpenSpec is not really suitable. A better approach would have been to complete this task directly without spec-driven development. So, for instance, by using PowerShell scripts or having a pre-trained agent skill. But it is still a good demo for how tedious and robotic spec-driven development can become. If the AI agent, in this case GPT 5.3 Codex, also has some inherent issues. For example, the big issue I have with this codex, every 3 seconds I have to approve some trivial action and for Codex to complete this action. Now, this is not a spec-driven development issue. It's outside of this topic. It's a scope outside of this topic. So, meaning that if I was maybe using a different model such as Claude, things would have been running a little bit more smoothly. Ultimately, the data access layer is completed, and all these repetitive code would have taken a long time if I had to do this by hand. But in this case, 5.3 Codex made an already boring robotic process of reviewing each spec task. This became even more slow, boring, and draining.